So, hey everyone, my name is Peter Bachfalucci with ITM Instruments. I'm a technical sales specialist. Thanks for joining us for this webinar via ITM University. Today's topic is acoustic lubrication with SDT ultrasound. We kindly ask that you mute your microphone during the presentation. Our presentation will last 40 to 45 minutes, and then we'll have time for questions and answers at the end. We encourage you to ask questions at any time. You can use the chat function that's in the dashboard to do this. ITM Instruments has been working closely with SDT Ultrasound for many years, and we pride ourselves for being a leading distributor of SDT Ultrasound. This is a result of our dedication to offering you our product expertise, service, and competitive pricing. Let's get started today with the webinar presented by Alan Rienstra. Alan is the Director of Business Development for SDT International, a Brussels-based manufacturer of ultrasound solutions, comprised of hardware, software, training, and consulting. A 28-year commitment to ultrasound applications has seen Mr. Rienstra play a role in the development of ultrasound-based solutions in 5 continents. He's also the co-author of Hear More, a guide to using ultrasound for leak detection and condition monitoring. Alan, we're ready for you. Please take it away.
I didn't know you were going to plug my book. That's awesome. Thanks so much, Peter. And I can tell that my bio is at least three years old because it's now 31 years, not 28. But everything else is pretty much the same. So thanks very much for having me, ITM Instruments. I'm really excited. I always like doing these virtual workshops, and I've gotten pretty used to doing quite a few of them for the last 2 years or so. Always happy to spend some time, sharing my perspective on rolling element bearing lubrication, the way it's done today, and the way that we think it should be done, and some of the problems that I see with the way it's done today. So, of course, I'm not just going to talk about problems. Problems aren't very useful unless I can also offer you some kind of solution. So I'll try to get through the problems and then leave some time at the end to hopefully propose some solutions. And then in the Q&A, if there's some other questions that can lead us towards a more reliable precision lubrication, then I hope that they'll be asked.
Sounds great.
So awesome. Away we go then. So if you already have an in-house lubrication program, your aim has to be for it to be world-class. And to me, that means precision practices. But many of you probably still apply grease to bearings based on a work order that might be dictated by your CMMS. Well, where does that work order come from? It doesn't come from your CMMS. It's printed out by your CMMS, but it's actually dictated to you by calendars and calculators. And that's not, in our opinion, precision, and it's definitely not what we would consider to be world-class. So therefore, for the next 40 minutes or so, I'm going to talk about prescribing bearing lubrication based on friction and not fiction. Quickly, just who we are, SDT Ultrasound Solutions. We are the world's favorite ultrasound company. We measure that not by the vast number of ultrasound instruments that we produce every year, but by the quality, the endurance, and the sustainability of the condition monitoring programs that we help all of our customers to implement, which is to say that we're not so interested in making sales as we are as following up how those sales turn into reliable programs. Our mission's simple: provide ultrasound solutions to help you anticipate failures, control your energy costs, and improve your product quality while contributing to the overall reliability of your assets. My work's gratifying, and I'm really happy to come to work every day and do it. Our values are what propel us forward, and sometimes the driving gets difficult, and we have to do a gut check. Anytime I need to do a gut check, I just look at these 3 words: respect, simplicity, flexibility. And if I can check those 3 boxes, then I know that I've made the right decisions for my company, for myself, and most importantly, for our clients. I'm coming to you today from my office here in beautiful Cobourg, Ontario, Canada. This is my home. It's a beautiful one, and I invite anybody that wants to come and drop into our office and visit us come and see it for yourself. We'd happy to be your hosts. As Peter said, our headquarters and manufacturing are all done in Brussels, Belgium, which is the wonderful capital of Europe, also a destination we're seeing. And recently we opened an office in Kolkata, India, so that we could serve that incredibly growing manufacturing sector. And Kolkata is an amazing city as well, not just for the incredible food and all of the colors, but also because they now offer ultrasound from SDT. And today we're going to take a look at the task of precision relubrication of rolling element bearings. It's my goal to help you look at this task from a condition-based perspective instead of a time-based perspective. And I'm going to tell you a story that's based on friction, not fiction. My name's Alan Rienstra. I'm the Director of International Business at SDT. And in my career, ultrasound is the only thing I've ever done. And after 31 years, I imagine it's all I'm ever going to do until I stop doing things altogether. So my love affair with ultrasound began back in 1991. And this would be the first time I ever picked up an ultrasound detector. And it was an old SDT 150. And incredibly, these things are still out in the market being used 30 years later. I used that thing to listen to the intake valves inside the Perkins diesel engine of my dad's tractor. And the next 30 years, I've just had amazing discoveries. New applications just keep developing for this versatile technology. And today, my passion for ultrasound is going through a bit of a transformation, to be honest. I don't spend so much time in the field anymore, doing sales and whatnot, but I put a lot of my accumulated knowledge to work developing courses, making presentations like this one, and just helping you to get the most from this technology that creates safe workplaces, reduces unplanned downtime, eliminates wasted energy, and helps us all create that elusive culture of reliability that everybody wants for their organization. Machinery lubrication remains the single biggest factor affecting asset reliability today. If you speak to experts on the subject, or if you look it up on the World Wide Web, or if you attend a conference, you'll hear most experts will cite that as much as 40 to 80% of bearing failures are rooted in poor lubrication practices. Getting this one proactive task right can contribute to a long, trouble-free life for your bearings. But if you get it wrong, and so many of us do, you can expect unplanned breakdowns, you can expect to engage in reactive firefighting, you will see your resources get quickly drained, and a culture of unreliability will spread throughout your organization. And there's nothing worse than an unreliable culture, because it is the single hardest mountain for any organization to try and move. And so here begins my story. And I like to use once upon a time because everybody loves a good fairy tale. Once upon a time is a great way to begin a tale that can recapture our memory of days that seem long ago and forgotten. But it's not all that long ago when our lube technicians were considered the mechanical gurus of the facility. And so with precision, these old timers mostly would inject the oily lifeblood into the assets that were so critical for the manufacturing. They were the first responders, but their job wasn't to fix and repair because they weren't always in reactive mode. Their job was to maintain. These were the people that had their finger on the pulse of the plant, and they knew when an asset was healthy. And they also had a sixth sense for when trouble could be looming. But gradually, these gurus disappeared and they weren't replaced. Coincidentally, it happened at about the same time that manufacturing industries were making the transformation from time-based maintenance tasks to maintenance tasks driven by condition-based evidence. And many plants began using vibration analysis and infrared thermography to predict when machines might fail. But what they overlooked was the fact that lubrication is actually the earliest signal that their bearings were failing. If they were picking it up with vibration, if they were picking it up with thermography, they'd already missed the window to correct lubrication. What's sadly ironic to me is that while an entire industry transformed from reactive repairs to evidence-based data-driven maintenance interventions, the lubrication team got left out. They didn't get to participate in this transformation, and that's really the shame. And in fact, the job of the lube technician was managed away completely. And in far too many instances, it was even disparaged. You hear terms, derogatory terms, like grease monkey to describe this job. By the way, I happen to believe that monkeys are pretty darn smart. Our emphasis on reliability and asset management has never been stronger today. If you attend a conference or a webinar like this one, and you'll listen to some of the latest trends, some of the latest concepts and the strategies for building a reliability program or a reliability team. Heck, you're listening to me talk about it right now. Today, what we're seeing is we're seeing this flood of new talent, and they're all streaming through the reliability doorway. And they're all ready to make a difference. That's fantastic. But they're looking for the jobs in reliability. And we need those. But my question is, why is nobody lining up in front of the lubrication door? What happened to our thinking to make it such an undesirable job title? If lubrication is the single biggest factor affecting reliability, and we all know that. If I was to ask you on a scale of 1 to 100, what's the most important task to ensure reliability of your assets? Almost everybody would say lubrication, and they'd rank it somewhere between 95 and 100% as being the most important task we can do. So my question to you is, why aren't new young technicians knocking on the lubrication door? What is it about this job where we can all stand up and say, yeah, lubrication is the most important thing, but none of us want to do it? To me, if we think it's the most important thing to ensure reliability, and if it's the one thing that we can do to create reliability, it should be the most noble profession, and everybody should be lining up to do it. I got a better question. In my graphic here, you can see two sidewalks, two moving sidewalks going into two doors. Well, why is there one door for reliability and another door for lubrication, when they should be considered so intricately related, so one and the same thing? Wouldn't we be better with one moving sidewalk just leading to a wider, all-inclusive door? I think it's time to knock down the siloed walls that separate the condition monitoring team from the lubrication team, when they clearly have so much to complementarily offer each other. I should try to pronounce that word better. And while we're doing that, if we can convince more people to come on board as lubrication technicians, then we need to provide them with modern tools, modern ideas, modern training, and of course, continuous mentoring. They need to be both capable and competent to grease bearings right, but that's not where this story ends. I didn't tell you all, but I'm a historian first and an engineer second. So let's go back a little further in time than where we are today. Okay, let's go back a lot further in time, actually. History is neither ours to learn, but it's not ours to ignore either. And history can never be denied because it exists. All we can do is learn from it. And we know that there is a history of poor lubrication practices, but lubricating our assets actually dates back to ancient Egypt. Yeah, 4,000 years ago, Egyptian lubrication technicians, or they were probably called something like oil pourers, used water, or they used tallow, or they used oil or duck fat to help lubricate the surfaces of simple sleds like this one that just went across the screen here. And they actually did it based on condition. Yeah, evidence-based feedback. When the sled became too hard to push, they just poured more oil. So what was their evidence? Their evidence was friction. There was an increase in friction. It became too hard to push the sledge, so they just poured more oil in it. We could build a flimsy argument that the Egyptians actually invented condition-based lubrication. They didn't invent ultrasound. They didn't know it existed. What happened 4,000 years ago to now? We just stopped using it. When non-lubricated or improperly lubricated surfaces come in contact with each other, friction's created. And in many cases, this friction is an energy waster, as well as a heat generator. Pouring a steady stream of duck fat or olive oil onto the surfaces used to be the best solution that we had. But times have changed and applications have evolved. Lubricating the bottoms of a sled so it can slide easier along the ground doesn't require the same precision as maintaining that thin film of lubricant that we need in our modern day rolling element bearings. For a sledge or a cart, too much grease is okay because the excess just squeezes out the sides. The Egyptians didn't even have to worry about the Environmental Protection Agency coming and inspecting all of the oil contamination that they would have left. Let's fast forward it to today. When we add grease to a motor bearing until it pushes out of the seal and onto your work boots is not the best measure of correct grease replenishment quantity, is it? With today's loads and today's speeds, a dedicated oil pouring person is a really poor solution. And so is using a calendar and an interval calculator to schedule relubrication tasks. It's 4,000 years and counting, and industry is still seeking a workable method to determine when and how much lubricant to maintain perfect separation of surfaces. Well, we often use statistics to help us make our story, contextualize our story. We can frame those or manipulate those statistics to suit our inquiry. Well, for rolling element bearings, it's a well-established fact that poor lubrication practices are the leading cause of premature failure. And as I said earlier, as much as 40 to 80% of reliability issues are rooted in poor lubrication practices. Now, 40 to 80% is a pretty big spread. Let me explain, not every industry is the same. So, some industries are more rugged and more durable and more difficult than others. So when you get into these really difficult, especially in an industry where you have a lot of high vibration, because there's nothing that kills that vibration, that lubrication film quicker than excessive vibration. Excuse me. But you will get anywhere from 40 to 80%, that being my point. Whether you're using the wrong lubricant for the application, you can have deterioration of the lubricant, lack of lubricant, or too much lubricant, or contamination, which could result from poor injection practices. It can also result from poor storage. A lot of times contamination happens in the storage room where you keep your lubricants. Sadly, contamination sometimes happens before that lubricant even arrives at your facility. In any case, all of those failures can be traced back to poor discipline and control over this important proactive task. So then the question I have to ask is, why is it that only 5% of maintainable bearings will ever make it till their L10 life expectancy? Hopefully everybody knows what their L10 life what the L10 life expectancy is, or what I mean by that. If not, you ask about it later and I can explain it in the Q&A. But the answer to the question, why do only 5% of maintainable bearings make it to their L10 life, is poor lubrication practices, such as the ones I just mentioned. Wrong lubricant, mixing incompatible greases, deterioration of the lubricant, the oxidization of the additives, and inadequate time intervals between replenishment intervals. If you're using a time-based regimen and you don't have the intervals scheduled properly between lubrication tasks, and that can be too short or too long, then that's also going to play on it. So all of these things have to be considered. But there's also a bigger question about why, or a bigger answer to the question about why 5% of maintainable bearings make it to their L10 life. And that is because we allow it to happen. We accept it as a cost of doing business because management doesn't always see the bigger picture. The cost of a failed bearing is always much, much higher than just the cost of the bearing. A $35 bearing can cause $1 million in damage. Unfortunately, too many of us just look at the $35 for the bearing and they ignore all of the other attributes, all of the other cost attributes. Another question then, why do we lubricate? Seems like a pretty simple question to me. Why do we lubricate? Yet when I ask that question, the answers I always get are not the same. Some might say, oh, well, we lubricate bearings to fight friction, Alan. That's true. Yeah, sure, that's true. We do add grease to an asset's moving parts to reduce that friction. But there's more to it than that. Some might answer that we do it to reduce heat. That's also true. Although if we put too much grease in the bearing, we remove the bearing's ability to disperse heat, but that's another topic. The right amount of lubricant does help keep moving parts from getting too hot. But some lube techs, they think that more is better. So they take it to the extreme. They add more grease, thinking they're doing good. And instead what happens is they choke the machine's ability to disperse the heat. The real reason to lubricate assets is to form that separation between surfaces, that thin little wedge of oil. And this logic applies not only to motor bearings, the pistons in an engine, the chains on a chain drive, gears in a reducer, even linear bearings that slide back and forth. They don't rotate, but they still have friction and they still need to be lubricated. And then sometimes you'll have a bearing that just does this, goes back and forth, back and forth. It's not doing a full rotation, but there's still friction and it still needs to be lubricated. The primary purpose to lubricate physical assets is to keep moving surfaces from coming in contact with each other. Because when they do, failure modes are initiated and the life cycle shortened. Friction is a force which opposes movement between surfaces. Friction increases wear between surfaces, increases system temperature, and dramatically increases the power consumption, the energy required to drive the motor. Delivering the right amount of lubricant creates that thin film between surfaces, and for as long as that film is maintained, it protects the asset from the wear and the heat while allowing it to do its job in the most efficient way possible. Now, some lubricants will offer us the additional benefit of controlling corrosion. They contain additives which present rust, acids, and moisture attacks. The grease has to be kept free of contaminants. We talked about that. But the very nature of the thickener which holds that base oil in place, allows us to pick up dust and grit too. So while the job of the thickener is to hold the base oil where it needs to be so it can feed the war zone of the bearing, that same thickener also holds on to things like dust and grit. When you think about thickener, think about a sponge that you might use to wash your dishes in the kitchen. And when you take a nice clean sponge out of its plastic wrapper and start using it, it's pristine and beautiful, but give it a couple of days or a week, it starts to smell a little funky, it starts to have some grit and grime in it. You certainly don't want to wash mama's china with that anymore. So think about that thickener as a sponge. And when you think about it that way, you get yourself a clearer picture of just how critical it is to keep it clean. Now, I mentioned something called the war zone. And I'm not talking about Russia and Ukraine. I'm talking about that part of the bearing where the rolling elements meet the raceway and the cage. And we talk about the region of the bearing where the lubrication mechanism does its most important work. And that's where the base oil bleeds from the thickener to create that thin hydrodynamic film of component separation, just like we see in the graphic here. So that's clear. When we lubricate bearings, and more specifically when we grease bearings right, we achieve low friction, low temperature, and bearings have the best possible chance to exceed their engineered lifespan. So our goal has to be to achieve that perfect lubricating film and maintain it, but unfortunately, it doesn't last forever. If it did, we wouldn't need this presentation, we wouldn't need ultrasound, and we wouldn't need lube technicians. We could just set it and forget it. But that's not our reality. Grease is an organic compound. And just like all carbon creatures, including us, grease ages and eventually it dies. So we have to replenish it. But there's a higher reason to grease bearings right. And it has nothing to do with what I just talked about on that last slide, separation of components. Proper lubrication can remove up to 80% of our reliability problems, which in turn allows our organization to thrive, to achieve its operational objective. If you want to get the attention of your manager, if you want to get sponsorship and funding to fix this lubrication problem, then the way to do it is to show them that the real benefit will be to your bottom line. More output, more productivity, less unplanned downtime, fewer angry customers, fewer parts in the storeroom, less grease being wasted, and a culture of reliability that everybody can get behind, that everybody can be proud of. When I say we've been getting it wrong for 4,000 years, that's not to say that the calendar-based methods were mistakes of our past. They were the best solution of a prior era. But today we know better, and we have better technology to support advanced decision-making. It's called ultrasound, and it offers us the ability to finally grease bearings right. Now we look at the phases of lubrication. What happens when we inject fresh grease into a bearing? Understanding the churning and the bleeding phases of grease replenishment are critical in tying together the role that ultrasound plays in ensuring we finally get this right. And by right, I mean a solution that provides guidance at each step of the grease replenishment task. A solution that tells us when to grease, how much to grease, which type of grease to inject, which grease gun should we use for the injection on a specific bearing, to provide confirmation that the grease actually reached the bearing, because it doesn't always, and to confirm that the task actually improved the lubrication mechanism, because we know all too often that maintenance PMs can make the situation worse, not better. But there's really three things you need to do, and it's three simple questions when you approach a bearing. The first thing I would say is, hello, Mr. Bearing, how are you today? Do you need grease? So I'm not even going to approach my bearing with a grease gun. I'm going to approach my bearing with ultrasound, and I'm going to take its pulse. I'm going to collect some data, and I'm going to say, how are you feeling today? If you're okay, I'm going to leave you alone. Even though my PM tells me I'm supposed to inject grease because 2,000 hours has gone by since the last time I did it, I'm going to leave you alone because you're just fine. And that's the mistake that we make. So question number one, do you need grease? Question number two, if it's a yes, how much? Well, we have a calculator for that, but that calculator might not be right. It is based on some scientific evidence, but if the interval between lubrication cycles is too short or too long, then the injection quantity on the replenishment will also be wrong. So in theory, the dimensions of my bearing may tell me that I should inject 50 grams of grease, in theory. But what if 20 grams of grease makes my bearing smile? If I can stop at 20 grams, I've done my job. And then if I can look at that data and say, all right, so 20 grams did the job. So for the next interval, instead of coming out at 2,000 hours, I'll come out at 2,200 hours. And then we'll compare the interval to the next injection quantity. Because all I'm going to do is, again, first question, hello, Mr. Baring, how do you feel today? Do you need some grease? Yes? How much? Okay, here's some grease. And then the third question, did I make you feel better? Did I leave you in a better condition than you were when I came to you? And sometimes the answer to that is yes, and all you did was came and walked away and you didn't do anything to it at all. Assessing the cause and effect of failure modes is a scientific approach to help us determine which technology is the best fit for identifying failure modes. And knowing which of those defects can be detected with ultrasound can save a lot of time and frustration. There's not much point in using the wrong technology to uncover a defect. Vibration analysis in the hands of a very well-trained, experienced technician can be used for lubrication. Ultrasound in the hands of somebody with minimal training, but a good concept of what good lubrication practices are, can net results much quicker with less cost and a lot less complexity. Ultrasound allows us to hear above the noise of the factory floor. By screening out low frequency sounds, inspectors can hear sounds consistent with machine system defects. And these defects produce ultrasound from 3 phenomena. And the first one starts with an F, and it's friction. The next one starts with an I, and it's impacting. And the third one starts with a T, and it's turbulence. Friction, impacting, and turbulence. If the failure modes of your asset produce any 3 of these, then ultrasound is the right fit for your reliability and condition monitoring program. And by the way, about 90%, 95% of the failures that will hit your facility all produce friction, impacting, and turbulence, which means that ultrasound should be your front line of defense against unreliability. Let's talk just briefly about training, because I'm super passionate about training. If we're still asking if training is important, and if you're still asking me, why do I need training, then I know that we have a lot of work to do. But sadly, there's vendors out there, and not just ultrasound vendors, but vendors of all kinds of technologies that insist that their products require little or no training. And they'll advertise them to you as, hey man, buy this stuff because you'll get results right out of the box. Love cliches like that. Results right out of the box, you'll pay for it the first time you use it, blah, blah, blah. If your solution provider attempts to convince you with free training or no training required, my advice to you is do 180 degrees and run in the opposite direction as quickly as you can. It doesn't exist. Our goal must be to create a team of well-trained lube technicians in as short a time as possible. Ultrasound has a short competency curve, but machine relubrication goes far beyond just learning how to push the buttons on the device, because it's not a device, it's a solution. Once we've created competent lube technicians, we also have to ensure that they're capable of executing on that solution. How can we do that? We do that by providing equipment, training, and a culture change that instills discipline and control over this most critical proactive task. And most importantly, we provide autonomy for them to think on their own. Some of the things we want to consider before we approach an asset is the asset safe to even access? Because a lot of times you'll come up to an asset being expected to collect some data or being expected to inject some lubrication, and there's something there that just doesn't suit your eye. As a technician in your facility, are you empowered to skip over that asset and say, sorry, I'm not going to do that today. It's dangerous. It's too dangerous to move forward. Well, we say you should be able to do that but you still need to be able to say why. Why didn't I do my job today? Well, if it wasn't safe, fine, but there needs to be some way, some kind of a messaging system that allows you to report that back to the team. Are all the measures in place to prevent contamination? And again, I talked about contamination a little bit. This course isn't, this talk isn't about contamination, but it's very important that oil be stored properly and that oil that you purchase should arrive at your facility in a clean state. And that's not always the case. Is the ultrasound equipment available when it's needed? A lot of times, once an ultrasound program really takes off, you need to purchase 2, 3, 4, 5, 10 devices because there's so many different applications beyond lubrication. And all of a sudden now, the lubrication technician is left without being able to use his device. Spilt water on my desk. That's a bummer. How about the lube routes that you have to walk? Because I know a lot of your facilities they're labyrinths, they're mazes, they're huge. And when the lube routes, were the lube routes created in a logical and efficient walking order? I'm playing golf tomorrow at a local course. I'm looking forward to it. I haven't golfed a lot this summer. But when I think about people walking through the plant in an inefficient walking order, it resembles my golf game. Because I spend a lot of time going from the right out of bounds to the left out of bounds to the right out of bounds and every once in a while I actually make it to the green. But I'm zigzagging. I actually tracked my steps once and I walked 12 kilometers on 18 holes. That is a lot of walking. That's a lot of zigzagging. It's important that you create lube routes with a logical walking order that's efficient so that you're going through the plant as quickly as possible. So there's a lot to consider in what I've just said. Now, what I'm going to go through now is, I don't know if there's 5, 10 different, let's say, features that I think that you should look for if you're considering to start an ultrasound guided condition-based lubrication solution. So these are, to me, the extras that SDT has put into their Lube Expert solution, which makes it stand head and shoulders above. I hesitate to do this because I want this to be educational and not a sales pitch. So I'm going to try and present these in a non-salesy way, but in a way that makes you go, okay, well, that's a good thought. So first one, does your acoustic lubrication solution remind you to inject the correct grease type? Because we all know what can happen if you mix incompatible greases. And I remember a story that a guy told me, I don't remember his name, I don't remember exactly where he was from, but I know he was in a water wastewater treatment facility in Southwest Florida. And they had a summer intern come in and they were trying to give him, keep busy tasks. So they gave them some lithium grease and said, no, it wasn't lithium. It was another type of grease. Anyways, it doesn't matter the type of grease. The point is that his job was to go out during a shutdown and lubricate all of the grid couplings on their water pumps, and just do that and nothing else. So away he went with his graphite grease, and he greased all of the couplings on all of the water pumps he was told to do. And he said, well, I really want to show I'm going the extra mile. So what I'm going to do is I'm already here. Why don't I grease the pump and the motor while I'm at it? And they ended up putting graphite grease into the drive end and non-drive end sides of the pumps and the motors and the couplings. Well, the only thing that survived from that, you can imagine, will be the couplings themselves. The rest they had to flush out. Okay, good intentions, but bad education. You should never assume that two grease guns are the same, even if they have the same part number, or they come from the same manufacturer, the same supplier. So you have to validate your grease guns. And I don't mean calibrate, because you can't calibrate a grease gun, because calibration means that you changed its state from before to after. But we can validate our grease guns because the Lube Expert solution from SDT wants to know that every shot of grease is the same, and they want to know how much that shot is. So it's real simple. You just get yourself a digital weigh scale. You could get a newspaper or a piece of paper towel, put it on the scale, tear it, give it 10 shots of grease, add it all up, divide it by 10, and now you know the average shot quantity per injection of your grease gun. You have to do it for all your grease guns. You can't assume they're all going to be the same. And when you're setting up your lube routes in our software, it's going to ask you, which grease gun are you going to use? The green one, the gray one, the black one, grease gun number 001, whatever. Okay, great. And how much grease does it inject? So you need to be prepared for that information. Does the ultrasound meter know what type of bearing is installed in the motor? Well, only if you tell it. These details are critical to the lubrication quantity calculation, the replenishment quantity, and of course, determining if the bearing should even be maintained in the first place. Because a lot of the bearings out there are non-greasable, right? They're sealed for life. We're only worried about the 5% that are actually maintainable. But in order to set up your lubrication program, the Lube Expert solution wants to know the bearing number, therefore the bearing dimensions, so that it can calculate the replenishment quantity, but also the amount for each injection. Because, like I said, if we're going to inject 50 grams of grease, we're not going to inject 50 all at once. We're going to inject a portion of that 50. We're going to measure and see, and then the next, and so on. So it's important that your ultrasound solution insists on knowing what the bearing number is. The running speed's also critical to calculating the replenishment quantity. You know, a slow speed bearing has completely different needs than something that's turning at 1800 or even 5000 RPMs. So your ultrasound software has to ask, what's the RPM of the asset? Because that's part of the calculation in determining what the initial injection quantity is going to be. Again, if it's 50 grams is the total quantity, we might only inject 30% of that on the first injection. The RPM plays a role in that calculation, and it needs to be asked and it needs to be known. Some bearings are fed grease from the side, others from the top through what we call an annular ring, or the annulus of the bearing. It depends on the bearing type. And this physical fact will impact the amount of grease that's required for replenishment. So again, if you're looking at an ultrasound solution for acoustic lubrication, make sure that your ultrasound software requires that you specify whether the grease is injected from the side or from the annulus. Have you ever gone to the grocery store and forgot to pick something up? Milk, eggs, bread, those are the common ones. Garbage stickers, depending on where you live. Well, that's why we make shopping lists, isn't it? Your ultrasound greasing solution, because it's a solution and not just a gadget, knows which bearings require relubrication, because you've already gone out and collected ultrasound data on them. So if you've got 100 bearings in your route and 20 of them are requiring relubrication today, your software should be smart enough to produce a list of just those bearings. And if it can produce a list of just those bearings, then it should also be able to produce a list of how much grease you're going to need, the types of grease that you're going to need, and the quantities of each type, as well as which grease guns to bring with you. And so what if your software could print out a report that says, hey, on your way out to grease those bearings, stop by stores and pick up 200 grams of this grease type, 300 grams of that grease type, and the black, the green, and the orange grease gun. Rather than getting halfway into the plant and realizing that you didn't bring the right grease gun with you, or you didn't bring the right grease type, or you didn't bring enough. That's annoying, and that's a time waster. So make sure that your ultrasonic solution is smart enough to make sure that you don't forget to pick up the milk. It should also have a messaging system that allows the lube technician to communicate with the condition monitoring team, not only to feed them the data about what the health and the condition of the bearing is today, but why did they skip that machine? Again, maybe it was a safety issue, maybe the machine wasn't running. Okay, well, you can't just skip it and not leave a message, so you have to be able to give messages. Maybe the grease line was broken, whatever. You have to be able to leave messages so that you can maintain control, discipline, and communication throughout the entire lubrication and reliability and condition monitoring team. Because now they're not just siloed, they're not all separated, they've all come together now. We've brought them all together. Ultrasound assisted lubrication solutions should monitor changes in the bearing's greasing mechanism every time you've given a fresh injection. If you don't have the ability to stop and check and see how your progress is with each injection, then you're going to end up over greasing your bearings. By monitoring the greasing mechanism in real time, the lube brain can adjust the injection quantity on the fly. And the net result is fewer over lubricated bearings and a decrease in the grease consumption per asset. And since the lube technician is already visiting the asset, why not simultaneously pull a set of data readings and provide the condition monitoring team with insights about the status of the bearing's health? Our SDT 270 has the Lube Expert program installed on it, and it can also pull vibration data, and it has a bearing fault frequency calculator. It's all there in one tool. Your lubrication technician can become a useful, meaningful component of the lubrication, of the condition monitoring team. And then finally, if you don't document the task and share it with the team, it never happens. So you have to be able to log everything, including the amount of grease that was injected, whether it was a successful or a failed attempt to lubricate the bearing, what was the condition of the asset, and so much more. All of that messaging has to be done. There's a growing community of lube experts out there. Here's a picture of some of our early adopters, but today those numbers are now in the thousands. So if you're ready to become a lube expert, all you need to do is visit www.bealubexpert.com or ITM Instruments, who are the wonderful sponsors of this message today. And I'm so thankful to ITM for the opportunity to share my views on acoustic guided lubrication and the Lube Expert solution. Now, I'm happy to field whatever questions there might be from that, Peter.
Thanks very much, Alan. If anyone has any other questions, you can put them in the questions area. But for now, we have 3 questions. The first one is from Dan. His question is, by using ultrasound, will we be able to get a better idea of the time interval between greasing period?
Yes, but that's not the point. The point is that we don't want to create an interval that's fixed. We want to pull data from our bearings each time we lubricate them, and then we want to look at that data afterwards and use that data to drive our strategy for that interval. Today, the interval between lubrication tasks is calculated using a formula based on 6 correction factors. If I try to remember what those 6 correction factors are right now, I'll probably look silly, but I know one of them is vibration, one's contamination, one of them is if it's a stop-start regimen, vibration, temperature, contamination, and there's a 6th one that doesn't matter. There's 6, so you have to know what these six correction factors are, plug them into the formula, and then that formula will tell you you should grease your bearing every 2,563 hours. Well, that's very specific in my opinion. Or it'll tell you every 6 months. The problem is that those 6 correction factors First of all, in some cases, they're guesses. In other cases, they're assumptions. But in every case, they are a particular moment in time. My contamination today could change by the time I go home tonight. So therefore, my interval calculation formula is no longer relative. What is relative is friction over fiction. So if I can use the friction and the results, the outcomes of my ultrasound-assisted lubrication program, now I can start to look at how many times I'm over-greasing bearings, how many times I'm getting failed bearings, how much grease consumption, how much grease I actually consumed versus how much I was supposed to consume, because I'm measuring everything around friction. And then I use those outcomes to drive my interval strategy. So my interval is never going to be a set it and forget it.
Great answer. I have another question here from Travis. He asks, does SDT offer solutions that can be wired into a PLC full-time instead of having, I guess, a lube technician monitoring the bearings?
Presently, we manufacture the sensors that go into those systems, and we're working on an automated lubrication system. And when it's better than anything else that's currently available, it will be ready for public release.
Okay. And should IR be used along with ultrasound to determine equipment and bearing health?
Infrared thermography?
Correct, yes.
I don't know if you need, I would say that ultrasound is your first indication of friction. Temperature is a lagging indicator. Is it an important one? Absolutely. But I think friction measured by ultrasound is more critical. The Lube Expert and the SDT 270 and the 340, all three of our data collectors do have a non-contact infrared thermometer, a non-contact spot radiometer built into them. So temperature is part of the data collection, but I wouldn't say that it would, I wouldn't take temperature as an indicator of over or under lubrication over friction.
Mm-hmm. Very good. Next question, how do we know how much time to wait for the grease to make its way into the bearing?
Yeah, well, that's all part of the Lube Expert solution. So it's based on the dimensions of the bearing. So we put the bearing number, and therefore by default the dimensions of the bearing go into the software, and then the RPM of the bearing. All of those two factors go into dictating what we call the stabilization time or the churning time. So when you inject fresh grease into a bearing, you can't help but inject some thickener into the raceway. And then it's the kinetic energy of the bearing that disperses that grease to the cavities of the bearing, where it can then bleed the base oil and the additives to the war zone. So there's always going to be a little bit of churning going on, and we have to patiently wait for that to happen. But the Lube Expert actually counts it down on the screen. So based on the dimensions and the RPM, a fresh injection of grease, and then it starts 10 seconds, 9, 8, 7, and then it takes another set of ultrasound measurements to determine if you did good or did bad to the bearing, and then tells you what the next injection of grease should be. So you don't really have to know, as long as you put the data into the software.
Okay, and then one last quick question. Do we have to have an expert in vibration to understand the issue with greasing and bearing wear?
No, you don't. In fact, what you end up doing is by marrying the lubrication technicians and the lubrication team with the condition monitoring team. When I say condition monitoring, I'm not just talking about vibration specialists, but all of the technologies that fall into that basket. Our goal is to knock down that silo that keeps the lube team separate from the rest of reliability, condition monitoring, vibration. And the data that we can feed to the condition monitoring team through ultrasound actually frees up the vibration guy, expert, specialist, to go out and deal with more critical things. Use ultrasound to deal with stage 1 lubrication failure, stage 2 subsurface bearing failure, and then let your vibration guy focus on stage 3 and stage 4 defects and more complex things. That should be part of the goal. And when that happens, you know that you've got a successful program.
Great. Alan, well, thank you very much. On behalf of ITM Instruments, we'd like to thank you for attending our webinar today. We hope you found it informative and helpful. ITM Instruments is available to assist you anyway. Just visit us at itm.com for anything you need. itm.com will have a list of the entire SDT ultrasound products, descriptions, and specifications, and you can find our contact information in order to connect with us for any technical support you might have. At the end of this webinar, we'll have a short survey. We'd like you to answer any questions to help us improve webinars in the future. And then we'll be having a draw for $100 to anyone that attended today for a gift certificate that could be placed online. I would also invite you to visit our website and look at the ITM University training section. We have some webinars coming up. There will be more on ultrasound. We also have an in-person webinar at different offices and locations across Canada. So Ontario, New Brunswick, Quebec, Alberta, we have 2, and also in British Columbia and Saskatchewan. So again, thanks for attending. And Alan, thank you very much.
Thank you. Appreciate it.
Take care, everyone.